Welcome back. It's time to write our own binary search tree. And in this exercise, I'm going to challenge you to write your own before you watch my solution video. Now keep in mind that just like with linked lists, it's going to require us to keep track of the nodes to the left and to the right of the current node. And also we have a value associated with a node. I recommend you actually draw this out on a piece of paper to understand, because keeping everything in your head and the calculations might be a little bit difficult. But I have started you here with all the essentials you need. We've created a binary search tree class. We have a node class that we can use. We start our binary search tree with this.root of null because we don't have anything yet. But remember, we have the root, which is our topmost node, which currently is empty. We're going to initialize our binary search tree, and hopefully we're able to create two methods. One is insert and one is lookup. And our goal is to create this tree over here. 9 as the root node, then 4 and 20 as its children, and then 4 has 1 and 6 as its children, and 20 has 15 and 170 as its children. So ideally, if we implement insert correctly, we can say tree.insert 9, then insert 4, then insert 6, then insert, let's say, 20, we'll insert 170, last two we'll insert 15, and we see we have 1 left here, so let's do insert 1. And ideally, after running these commands, you're able to create this tree data structure. Now, at the bottom here, I created a small little function for you. And for now, I want you to just ignore it, because we're using something called recursion here, which we haven't gotten to yet. But I only created this function for you to be able to test out your code to make sure that it actually works. All you need to do in order for you to verify that this is working is to say json.stringify, which is a JavaScript specific way to create a JSON string. And we're going to say traverse tree.root. We just give it the root node of our tree, and it's going to traverse and print out everything into a string so that you can check in the console that your tree actually is working. And in the solution video, I'm going to demonstrate how this works, but I've added this as a little helper for you in case you want to double check your work to make sure that it's correct. And by the way, the lookup method should simply return the node that we're looking for. And if it doesn't find the node, then we can return null or false, whichever you want. And I've added the remove method here, which we're going to talk about later because it's a little bit difficult. So for now, just worry about insert and lookup, and I'll see you in the solution video. Bye-bye.